As the bird flies, 2.5 million solar modules swimming in more than 2,500 acres of land, with 8,500 pairs of hands at work during the peak of the project.
No challenge is too big for us, no goal too far.
Putting up an ambitious display of the finest in solar technology.
Our robotic system does not use any sort of water or electricity,
while racing towards a tight deadline.
Managing the engineering, procurement, project management, and site construction in such a short span was a huge challenge.
Even when Mother Nature decides to throw in a few surprises,
we went to hell and back.
the team would try not to let anything eclipse their progress.
We are planning for taking precautions during partial solar eclipse.
As they braved breakdowns and delays,
check करो, one fan was off.
30 kV का लाइन अनस्टेबल हो गया है तो टोटल ग्रिड अनस्टेबल होने के लिए चांसेस ज़्यादा है.
aiming to make one of the world's largest solar power plants in a single location in an unassuming part of southern India. 648 megawatts of clean, green electricity will soon be generated and exported to the South Indian state of Tamil Nadu by March 31st, 2016. And putting this massive solar power plant together on time is a team of dedicated and energetic engineers, contractors, and personnel at Adani, one of India's leading infrastructure conglomerates. This is an inside look at a megastructure that is India's solar powerhouse. Bright and fiery and mighty generous, our glorious sun has always been radiating light and beauty. But never before has its power been harnessed the way it has been in the 21st century. And now, more than ever, with depleting fossil fuels worldwide, the sun takes center stage.
India is one of the fastest growing economies, and energy is a crucial part for economic development. Huge demand for energy has led to vast utilization of natural resources. To meet this surging demand, solar energy is the best form of energy.
Energy from sun is free. Nowadays it's powering airports, kitchens and planes, and it's going to the future.
One country is taking long and fast strides towards a national goal of becoming one of the world leaders in solar power generation by 2022, India.
We have set ambitious targets. By 2030, we will reduce emissions by 33 to 35% of 2005 levels and produce 40% of our power from non-fossil fuels. We will achieve it by expanding renewable energy, for example, by adding 175 gigawatts of renewable energy generation by 2022.
That's a huge energy commitment, especially as India is generating only around 1/5 of its goal right now, with some 36 gigawatts of renewable power generation. Out of this, only 4,060 megawatts of the power generation comes from solar, a number India wants to inflate to 100,000 megawatts by 2022, or powering nearly 60 million Indian homes. Something like electrifying 1 1/4 the number of households in the United Kingdom. And for that, India needs something mega.
So as a solar power producer, our land requirement is huge, and you know land is a difficult task in a country like India, which is highly populous.
The solution lay near the South Indian city of Madurai and Tamil Nadu, which is home to a unique structure that has captured the imagination of pilgrims and tourists alike. The Meenakshi Temple, 14 gopurams of this awe-inspiring Madurai Meenakshi Amman temple rise into the sky. This ancient place of worship welcomes thousands of devotees every day who come to seek the blessings of goddess Meenakshi and her husband Shiva. The temple is famous for its 1,000-pillar hall, an architectural marvel constructed way ahead of its time 2,000 years ago. It is only fitting then that some 90 kilometers away from Madurai, in a little-known town called Kamuti, arises a megastructure that has the potential to be monumental in its own way.
For such a mega-sized solar power plant, we require a huge patch of land, also the good solar radiations and the proximity with port for logistics purpose. And all this we found at Kamuti in Tamil Nadu, and this was the beginning of how we started this project.
The Adani Group claims its plant will generate a maximum of 648 megawatts of power, making it one of the world's largest single-location solar power plants.
India has a tremendous scope of generating solar energy, and it is high time we concentrate more on conservation of resources.
Solar radiation is one of the most important factors in power generation. Solar irradiance is the measure of the amount of sun rays that falls on the surface, a happy problem of plenty in a country like India, which basks in the sun for around 300 days a year.
तमिलनाडु रामनाथपुर डिस्ट्रिक्ट में सोलर इरेडिएशन बहुत ज़्यादा है, इसका वजह से यहाँ पर प्रोजेक्ट लगा।
When the engineers from Adani reached the site at Kamuti in July 2015, they realized the gigantic task at hand. The total land allocated for this project was 2,500 acres. That's like packing in nearly 60 Taj Mahals on a patch of land. Over time, the company had acquired the land needed for the project. Now what had to follow was some intense planning and rapid-fire execution to meet the deadline.
The size of 648 megawatt in next 8 months period is unimaginable for anybody.
For the team, that meant slipping into overdrive from the get-go.
We are planning to have all the infrastructure facility in place in the month of August, this month only. So we are planning to build a huge site office, and we are planning to have the illumination facility so that we can work round the clock.
It wasn't going to be easy though. One of the initial challenges in a remote agrarian non-industrial town like Kamuti was sourcing manpower and equipment.
Nothing is available, and anything, the nearest town is Madurai, which is 90 kilometers away. Even to get a couple of vehicles, you need to hire from Madurai. So getting planted machinery from nearby is ruled out.
And if they didn't get their machinery in place, the engineers would be in trouble. The first load of containers was arriving by late August from China. These containers with solar modules and module mounting structures would need a home immediately, a very large home. 140,000 square meters of space. Imagine nearly 6 Sydney opera houses stacked together. That's the kind of area this project would need as storage. It's August 2015, and the team at Adani is scrambling to get the open storage area ready for the hundreds of containers that would soon be unloaded at site.
When we landed at site and the magnitude of the work we need to do it, we thought we had bitten more than what we could chew.
By September 2015, the shipment from China had started arriving, and the site was nowhere near ready.
Major task is, you may get to site, but how do you do unloading? And where do you store?
No one in the world has attempted setting up a solar power plant of this magnitude. Critical components like inverters would need closed warehouses. When these weren't getting ready in time, the project management team had to make some quick decisions, like hiring go-downs at Kamuti till the warehouses on site got ready. That would happen only by mid-October, a delay of more than a month from the time the containers started arriving on site. For a large-scale project on a tight deadline, this was not the start the team was hoping for. It was already September, just 7 months left to the finish line. Only after sorting all of this out could the team get cracking on actually installing solar modules that will eventually generate electricity. Solar energy works on a simple principle. The sun's rays fall on solar cells, which convert sunlight into electricity. When sunlight hits the surface of a panel, it excites electrons in the cells, and they start to flow out as direct current. The direct current gets converted to alternating current using inverters. And finally, in most cases, this clean and renewable form of energy gets exported to the grid on a large scale. Once the land was acquired, it was all hands on deck, with design and execution powering through simultaneously. With 7 months still to go for commissioning, work began full steam at Kamudi. Around the same time, the head of protection and metering, Sumit Sharma, was one of the men tasked with thinking through the data monitoring and control systems that would eventually be installed at site.
See, when you have a geographically spread installations, then it's difficult to manage the system manually. And you need an automation system which can actually give you information, and you are also able to do control operations for the spread out installations. That system which is utilized for such a widespread installations, we call it SCADA.
And this particular supervisory control and data acquisition system, or SCADA, was installed for a particular feature. Internally called the control philosophy, this feature will allow for limits to be set remotely on power generation. Depending on the grid requirement on any given day, instead of field engineers being sent on site to turn down inverters according to the grid's demand.
Since we are building a very huge solar plant of a scale of 640 megawatt power, the fluctuation in our solar plant will be actually affecting the grid operations. So in that case, the grid operations will request us to actually maintain the power of your plant at a fixed output. So you need an aspect in the SCADA system, in the control automation systems, which can help you do that function.
Meanwhile, on ground at Kamudi, there were not a moment's rest to be had. Less than 7 months left to complete installation and plenty of ground still to be covered. First, level the large tracts of land and grade it using graders. The long blades level the land and prepare it for the next step, plotting. Surveyors sweep into action and start marking points on the ground. Piles will be driven into these exact points. Piles are structures made of steel that will eventually support the all-important solar module.
What makes it the difference here is the size of this plant. To complete the whole project, around 3.8 lakh pile bore we have constructed.
टाइम ऐसा रहेगा कि एक दिन में 1200 से 1500 और मे बी अप टू 2000 तक फाइलें हम लोग डेली करेंगे.
The large number of piles was throwing up a challenge for the quality team. For almost 400,000 piles to be laid on site, the team needed several contractors, and they all had to be brought up to speed on standard operating procedures and how to make the perfect pile.
We had a new workforce coming in from all parts of the country. We had also turnaround of workforce as well as contractors, and we had to also push the contractors to the degree that they are punching above their weights.
All of this was eating into time the team didn't have, especially people like quality manager Manoj, who had to supervise this simple yet critical process. He had to ensure that the piles pass a pull-out test. A pressure of 1,200 kilograms per square centimeter is applied to the pile, and if it stays put in place, it passes the pull-out test, an indication that the pile can survive high wind speeds and any other force of nature. Eventually, 2.5 million modules will rest easy on these tables of galvanized steel. The panels alone will occupy an area of 1,270 acres, enough to take in 476 football fields. These module mounting structures, or MMS, have been grouped into tables with a specific capacity. One table can generate almost 50 kilowatts peak electricity. The amount of metal being used to make these piles, tables, and towers is mind-boggling. Around 30,000 metric tons of galvanized steel. You could construct more than 4 Eiffel Towers with that much steel. The entire 648 megawatt plant is made up of clusters of modules of 4 to 5 megawatts each, and inverters are linked to the solar modules. An inverter's job is to convert direct current into alternating current, and 144 pre-engineered buildings are being made just to house the 576 inverters required for this plant. All this would require a lot of cabling. Wires of different shapes and thicknesses are connecting the dots in this massive solar puzzle, almost 7,700 kilometers long. These cables can run all the way from New Delhi, India to Perth in Australia.
ST cable, this is a highly manual intensive process, and 50 persons are required for pulling 50-meter cable at a single point of time.
After all this heavy lifting, the engineers finally started installing solar modules only in the month of October 2015, and they had set themselves an initial daily target to install 3 megawatts a day, so that in 6 months, and with a little push towards the end, they complete 648 megawatts.
And internally, we kept 3 megawatt as a benchmark for us to develop this plant. But many people are still laughing at us. How can a 3 megawatt can be done?
It's a busy site with clusters of solar modules, dedicated inverters, control rooms, switch yards, and substations coming up, like an assembly line for power generation. The company's game plan is to keep commissioning pockets of electricity leading up to the final evacuation or exporting of the total capacity of the plant to the grid towards this. The site is being divided into 5 units of different capacities.
Before us, the largest solar power plant at a single location was in California in US. That project was completed in around 3 years. We were looking for setting up 648 megawatt, and that also in less than a year.
On-site and off-site, though, there were some dark clouds looming and waiting to wash away plans, deadlines, and dreams. It's the end of October 2015, 5 months to go for one of the world's largest single-location solar power plants to come up in Tamil Nadu, India.
Projects gets completed within schedule and within the budget. These are the 2 main parameters for measuring the success of the project.
And now, to pull off something like this, Sumit and his team were going to have to work closely with ABB, the power and automation company that was executing the SCADA system for the plant. The folks at ABB have called the engineers from Adani to test the plant monitoring SCADA system and its control philosophy feature. The testing and automation engineers had allotted 2 days for checking out the customized SCADA before shipping it off to Kamudi in order to deliver the systems on time to the site. But that didn't happen. 2 days became 1 month, another timeline setback the engineers had to absorb.
Challenge was that we had multiple suppliers of equipments. For example, the relays, the control and protection relays, the inverter themselves, and all of that has to be validated with the supervisory control and data acquisition system. Now, to do that, in some situations, it was not possible for us to get the actual equipment.
While one set of engineers were busy testing the SCADA system in Bangalore, back in Kamudi, work was slowing down for the rest of the team as the northeast monsoons descended upon South India.
Actually, we planned this project to complete in 8-month duration. So in the normal way, we are heading with 3 megawatt per day of module mounting structure and module installation. And during the monsoon season, it goes down to 1.5 megawatt per day basis.
But things did not go as per plan. The reason being the 2015 Northeast monsoons. Met experts pinned it on the El Nino effect as one of the reasons behind the devastating floods that hit parts of Tamil Nadu and other parts of southern India. The rains ravaged cities and towns, and the last 100 years hadn't seen water work as mean and devastating as the 2015 flood. Meanwhile, the teams were missing every internal monthly target.
बारिश की वजह से एक बार हमको ऐसा लगने लगा था कि ये जो गेम है और ये जो हमने पूरे एफर्ट्स किए हैं ये हम हार जाएंगे.
In October, they managed to set up only 1.6 megawatts of solar module as against the target of 90 megawatt. They should have set up 80 inverters. They managed only 10. They wanted to build 20 pre-engineered buildings to house the inverters. They hit 0. Barely 50 kilometers of cables were laid when they were hoping to lay 10 times the length. November didn't look any better either.
Looking at the time lost due to these monsoons, we were in shambles. Do we able to now reach our target by March to complete all these leftover jobs and to reach the 648 megawatt? We really lost hope to reach there.
If it was possible, things took a turn for the worse in December 2015 when work came to a grinding halt.
Yeah, well, I'm from Tamil Nadu and I haven't seen this degree of rain any time in my life. And we had huge amount of rain coming in a very short span of time. As a result, the whole land became swampy and marshy. Really, it was a very, very horrific scene.
The water may have been just knee-deep at site, but the logistics got hit hard when the team got word that Tuticorin, the port town closest to the site, was badly affected by the rain.
Our whole site is filled with water. The Tuticorin port was completely stopped. The logistic chain was not working, and we were absolutely the standstill for these 3 months.
The port at Tuticorin, some 110 kilometers away from the site, was a crucial part of the operations.
100 containers to Raja, 100 more containers from St. John Arc to Raja again, and these 200 structured containers are being sent to air shipping.
It's one of the 12 major ports in India and is located in the Gulf of Mannar. Just for this project alone, the port will receive more than 6,000 containers from all over the world, including countries like China, Japan, Malaysia, Taiwan, Israel, Italy, Germany, Turkey, and Switzerland. Less than 4 months were left. Damage control was the need of the hour. The corporate office in Ahmedabad was weighing in on their ideas too.
Let us accept this as a challenge and we go ahead.
Plan it accordingly by next fortnight and by next month.
An emergency meeting with all departments at the site office is underway to assess the damage and plot the way forward.
So the villagers are safe, but the only thing is that we need to rescue ourselves.
400 of my containers are waiting in the port and there is no storage.
The group has to take some drastic steps. With rain pelting down, logistics were proving to be the biggest challenge of them all.
ज़्यादा बारिश होने के कारण हमें काफ़ी दिक्कतों का सामना करना पड़ा. इसमें हमको रोज़ का 100 कंटेनर अनलोडिंग करने का टारगेट था. तो हमने क्या किया, एरिया ज़्यादा कर दिया. हमने 4 सेगमेंट में अनलोडिंग एक साथ में चालू किया.
हम लोगों ने सबसे पहले इस पोर्ट के एंड पे जो है 24 घंटे वर्किंग स्टार्ट किया, जो पहले हम 12 घंटे में काम करते थे. इसी तरह से हमने रिसीविंग एंड पे भी अपनी शिफ्टों को जो चेंज करके 3 शिफ्टों में लोगों को हमने काम करने के लिए कहा.
From 2,500 workers on site, they had to pull in more than 3 times the number, nearly 8,500, and 24 hours in a day would not be enough.
our asking rate close to 10 megawatt. So 10 megawatt means 40,000 modules we have to place in one day. It's a Herculean task. We are pushing all the material in the night, so that by the time when majority of the worker comes in the day, they will be available with the resources.
The focus shifted to making up for lost time. That meant working day and night for a few months on the trot. By the end of 2015, though, the plant had slowly started to recover and was gunning for a 648 megawatt commissioning in the next 3 months.
The monsoon of this financial year was vigorous, and we allowed the water to flow into the nearby ponds and drains. And in future, we will see that proper pathways are made, drains are made, so that it gets into the local drains and ponds.
As the monsoons receded, hundreds of containers were making their way from the port in Tuticorin to the site, ready to be unloaded. The company has sourced components from multiple vendors across the world. For instance, 8 different manufacturers from China, Japan, Malaysia, and Italy are supplying just solar modules alone. 2015 ended up on a terrible note for the ambitious solar power plant. Almost at the point of giving up, the team had got a second wind and plunged themselves into work. The personnel on site had to install 126 megawatts of solar modules in January. With a round-the-clock attitude, they punched in 163 megawatts. But the engineers were struggling with their inverter deadlines, barely installing 40-odd inverters when they should have done 112 in January alone.
जब भी हम इन्वर्टर इंस्टॉल करते हैं तो सबसे बड़ी चैलेंज हमारे लिए होती है सेफ्टी। हम उसको पूरा प्रोसेस करते हुए इन्वर्टर इंस्टॉल करते हैं।
Back in the control rooms of the plant, the SCADA system was getting installed and tested on site. Portions of clean green solar power were starting to get evacuated from the plant. Already, there are officials from the Tamil Nadu Generation and Distribution Corporation to do some preliminary checks on site.
There are a lot of exercises which are required because what we are connecting when the plant of this size is actually getting connected to the power grid, or the disturbances which can happen is important, and we have to isolate the sections as soon as the fault happens so that the national grid is not disturbed at all.
At the end of the day, when it comes to electricity, a grid has to always remain stable. It's February 2016. The time had come to test the premise behind the control philosophy in SCADA, when the grid asked for only a minimum amount of electricity to be exported on any particular day.
Okay, sir, we'll reduce it up to 50% of the present load, sir. Sir, हमें अभी load का जो है 50% करना होगा, sir.
Okay, we are at 50 megawatts now, and we have to make it 25. Let's make it the set point to 25 megawatts now. Okay, done? 25. It's responding?
Yes.
Perfect.
Now, suppose my inverter is generating 1 megawatt at a given point of time, and I want it to generate lesser. I can give a command from the SCADA, from the screen, and it will generate 500 kilowatts only, as per my requirement or as per the grid demand.
Plant monitoring systems also give an accurate indication of electricity being generated literally every minute. Solar power production generally peaks between 11 a.m. and 2 p.m. However, sometimes there are factors that affect solar power production.
So typically in a power plant, the output depends on the radiation level on a given day. This project is spread over an area of 2,500 acres. So it might so happen that one small part of this area has a cloud cover. So generation in that part might be affected momentarily.
And if not cloudy or rainy day, electricity generation can take a hit if modules are dusty. Luckily, solar power plants are relatively easy to maintain. An average photovoltaic cell may last 25 years or more if you regularly clean the module. In Kamudi, What would otherwise have been a manual and water-intensive job has now been mechanized with state-of-the-art robotic technology from Israel.
The robot is being powered by a solar panel that charges during the day the unit's own batteries, and the robot will go for a clean every evening.
Waterless cleaning technology is a game changer for semi-arid dry regions like Kamudi, where it is a scarce resource. This robotic solar panel cleaning system uses soft microfiber on wheel that push dust off the modules. The robotic system can be remotely monitored, managed, and controlled. The site at Kamudi was beginning to take shape through January and February, where more work was done in 2 months than the preceding 5. But March was upon the team, and 300 megawatts of solar modules still had to get installed. And that meant putting up 12 megawatts of solar modules a day without a miss. Not easy, especially when there are a few surprise tests in store for the plant and the men behind it. The people of Kamudi in the southern Indian state of India, Tamil Nadu, were hoping the worst was behind them. The exceptional monsoons had receded, but along with that, so had the timelines for the engineers on site who were trying to build one of the world's largest single-location solar power plants. As February drew to a close, there were some nervous engineers on site, wondering if the inverters would be ready on time.
अभी तक हमारा चैलेंज सबसे ज़्यादा जो रहा है मौसम का चैलेंज रहा है, क्योंकि इस टाइम तक पहुंचने के लिए हमें 2 महीने मौसम ने डिस्टर्ब किया।
Out of the 576 inverters required, 205 had still not been installed or connected. Despite the grim statistics, there was an incurable optimism setting into the team.
Now it's not the time to look back. We have a lot of work to do. So focus ourselves. How do we do it?
हम लोगों ने जो प्रयास किए हैं उसमें हमारे को ऐसा लगता है कि एक हारा हुआ गेम हम वापस जीतने जा रहे हैं.
With renewable energy like solar power getting its time in the sun in India, there is a strong case building up for solar, whether it's a mega park or on someone's roof.
The trend is very promising. Rooftop solar is classified as industrial, commercial, and residential. Going by statistics, for a state like Tamil Nadu in India, it's added about 19 megawatts of rooftop solar, out of which 4 megawatts is in the residential rooftop solar itself. So there is a growing awareness.
Naricha and Arvind installed a 3 kilowatt solar power plant on their apartment terrace in Chennai a couple of years ago. Then they took it a step further.
We have an electric car, and I like to think of my car as running free because it powers off the solar plant.
And the area under the solar plant, I can use it as I've made a small rooftop garden.
Naricha and Arvind may represent a growing population of independent power producers, but for scale and impact, mega solar power plants, like the one almost completed at Kamudi, can make a big difference to power generation. With just a few weeks to go before the completion, the operations and maintenance team were finding themselves troubleshooting a fair amount. Control room in charge, Serenivas, and his colleagues are investigating the alert messages flashing on SCADA.
You just go and check in a panel room, what happening is there, and inform me.
Train, come in.
The transformer in the switchyard was overheating because a fan had broken down. A transformer's ambient temperature is around 50 degrees Celsius, but now it was a hot 83 degrees. And if the transformer trips, it could spell trouble for the plant and the grid.
Come in, fans are on, temperature is decreasing. Okay. एक्चुअली ये ट्रांसफार्मर ट्रिप हो जाएगा. हम लोग ज़्यादा जनरेशन दे रहा उसमें 100 मेगावाट दे रहा, एंड मोर ओवर 230 केवी का लाइन है. यदि 230 केवी का लाइन अनस्टेबल हो गया तो टोटल स्टेट ग्रिड अनस्टेबल होने के लिए चांसेस ज़्यादा है.
With renewable energy, it's always a two-way street. A solar power plant operates on the principle of making hay while the sun shines. But come sundown, solar power production stops. Unlike an off-grid system that stores power in batteries and kicks in when there is no electricity, a power plant like this is what is called a grid interactive solar power plant.
Typically in a solar power plant, the generation stops around 6:30 in the evening. But we need power to run equipments like SCADA, lighting systems and so on. So we take back power from the state electricity board. This is called backflow. Essentially, backflow is we taking power from the grid to power our systems here whenever we are not generating power.
Young engineers like Shariram and others have to keep their eyes on the finish line. With 20-odd days to go, the team still has to install 180 megawatts of solar modules. Can they do it? Or did they bite off more than they can chew? Especially when there were elements at play that would eclipse their progress. As of 2013, around 1.2 billion people around the world have little or no access to electricity, and more than 20% of that population lives in India. In the year 2022, India will celebrate 75 years of independence. The present government has a vision to provide 24/7 affordable, environment-friendly power for all by 2022.
We are not just thinking of the welfare of 10,000 odd people working for us. We are also thinking of all the people of India.
And plants like these are fast helping bridge the demand-supply gap in the nation.
हम इस सूरज की जो कुदरती ताकत है उसको यूज़ करके, उसको कन्वर्ट करके रात को यूज़ करेंगे। यहाँ पे कितने सारे घर हैं जिनको रोशनी की ज़रूरत है। We will use that power there.
Vanchi and his friends who live and study in Kamuti will be a few of the many beneficiaries of one of the world's largest single-location solar power plants when commissioned.
நான் 10th ஸ்டாண்டர்ட் படிக்கிறேன். சோலார் பற்றி தெரியும்னா மின்சாரம் அதிகமாக கிடைக்கும். சூரிய ஒளி மூலம் மக்களுக்கு பாதிப்படைவாங்க பல பேர். சோலார் இருந்தனால எங்களுக்கு இப்போ ஸ்கூலில் படிக்க மிகவும் நன்றாக உள்ளது.
There was a minor curveball coming the way of the engineers. India would see a partial solar eclipse on the 9th of March between 5:05 and 6:47 a.m.
Solar eclipse presents one of the biggest fluctuations to a solar plant, whereby in a very, very short span during a total or a partial eclipse, the energy production from a plant decreases and then suddenly rises exponentially, which could result in brownout fuses.
Though the partial eclipse would happen in the wee hours of the morning, when solar power production would be quite low, the team wanted to use the natural occurrence as a test run of sorts for the future to see if the engineers and the plant could handle the fluctuations that eclipses may cause in a power plant.
We are planning for taking precautions during partial solar eclipse. इतने बड़े सोलर प्लांट में अगर ग्रिड को नहीं बताएंगे तो ग्रिड अनबैलेंस हो जाएगा। फिजिकली ये भी जानना जरूरी है कि सोलर एक्लिप्स का क्या कंडीशन है, इसलिए 2 लोग हमारे बाहर से देखते रहेंगे उसको विद सेफ्टी ग्लास। कंट्रोल रूम में ग्रिड की मॉनिटरिंग चलती रहेगी और जैसे ही सोलर एक्लिप्स ओवर हो गया हम लोग जाके प्लांट में देख लेंगे फिजिकली क्या क्या प्रॉब्लम है, उसको ठीक करेंगे।
The sun played peekaboo briefly, but the engineers read the game well and set a plan in place for future eclipses. Back at the site, with 15 days to go before commissioning, there was a stock-taking visit by the CEO of Adani Power, Vineet Jain. There was a lot riding on the plant, and he had to motivate, supervise, and ensure completion if the company had to honor its contract with the state of Tamil Nadu.
I was not very sure whether we will be in a position to complete the balance work by the end of the month.
Roughly 120 megawatts of solar modules still had to get erected. Supervisors of every department were pushing their teams to keep up the pace. You could sense nervous energy on site at Kamuti. The last clusters of panels are being erected, connections made, system checks completed.
हमने इस प्रोजेक्ट को पूरा करने के लिए जी जान से एक कोशिश की है और हमको ऐसा लगता है जैसे हम दो यूनिट ऑलरेडी इसकी कमीशन कर चुके हैं और हमारे को पूरी उम्मीद है कि 31 मार्च तक हम बाकी 3 यूनिट भी कमीशन करके पूरा कर देंगे।
It's the morning of March 31st, and the team at Kamudi are still putting modules on structures, while engineers rush about checking these modules and making sure they are working. 360 megawatts is already being evacuated to the grid, and the remaining would flow out as soon as the state grid gets ready to receive it.
It's a proud moment of my life. Together, we achieved the unachievable.
648 megawatt solar power plant is a big pride for all of us, is a big pride for Adani Group, is a big pride for Tamil Nadu, and is a big pride for this country.
For the entire Adani Group, March 31st, 2016 turned out to be a real good day at the office.
Everybody, and the celebration begins now!
This solar power plant will light up the lives of millions of people. A true mega structure.
And a baby step towards the company's next target, setting up a solar park in Rajasthan to generate 10,000 megawatts of solar power by 2022.